Alright, here we are at the beginning of 1.7, at the end of chapter 1, and you know, I know this is a time when hopefully everything's been working well for you. Hopefully you've been asking lots of questions in class, and soon we'll be having that test. And so when we have that test, how is that going to impact you, and how is that going to impact your grade? So yeah, the one thing you do need to know is that your tests in this class will represent about 80% of your overall grade, and your homework and everything else will represent about 20% of your overall grade. So could have a good grade going right now, but it's important that you get ready for this upcoming test. Obviously this will be coming to play after this section, but you know, one thing I would do is rewatch some of these videos, pick up the stuff that you don't know. So alright, let's get started. Absolute value. The key to absolute value is that it is the distance from 0. A lot of people say, oh, it's always positive. Well, there's sometimes that you can get pretty confused with absolute value. I always want to just think about its distance from 0. So if I said, what is the absolute value of 3, you would say, oh, it's 3 units from 0, so then its absolute value is 3. What is its what about negative 7? Well, negative 7, it's 7 units from 0. So we have an absolute value of 7. And then an extraneous solution is a solution that looks to be like the right solution, but it doesn't check. And so you, at the end of a problem, you might say x equals, you know, something might start like this. Let's say 5 equals 7 over x or something, or it ends up being something over x, and you know that you can't put in there what cannot be on the bottom. You can't put a 0 in there. So let's say at the end of doing all of our work we had a 0. Well, then that would be an extraneous solution. You can't have a 0 on the bottom of a fraction, or you can't have a negative on the inside of a square root or something like that. So those would be extraneous. Alright, so when you're interpreting these things, when you're interpreting the absolute value of equations, they have a lot of verbiage here and a lot of words that may or may not mean something to you. I'll try to go through it quick because I think when we get to the numbers it'll make a little bit more sense. When you're doing absolute value, if the absolute value is equal to the absolute value of x minus 0, okay? And the distance between x and 0 is called k. Okay? So x minus 0 equals negative k, or x minus 0 equals positive k, then x would be negative k, or x would be k in that situation. Because anytime you minus 0, it's not really going to change much. So if I said the absolute value of x minus b equals k, the distance between x and b is k. Alright? And on the bottom here, x minus b equals negative k, or x minus b equals positive k. Well, just flip that around. If I add k to that first one, I end up with b minus k. Or if I add k to the second one, I end up with b plus k. Now, for some of us, that might actually mean something. For some of us, we say, oh, let's get on to an example so I can actually see what this means. That's where we'll go right now. So we have an example here. And in our example, the absolute value of x minus 3 is 6. That would mean that the x minus 3 could either equal negative 6, or it could equal 6. And how I always think about that is I say, the absolute value equals 6. What could I put in here? Oh, I could put a 6. That would work. The absolute value of 6 is 6. Or I could put a negative 6. The absolute value of negative 6 is 6. So I could put either one of them. If I added 3 to both sides on this one, or made it negative 6 plus 3, then negative 3 would work in there. Or if I added 3 over here, I have 6 plus 3, and I end up with 9. Now, so the solutions would be negative 3 and 9. These are the values of x that are 6 units from 3. Okay, so if you if you start at 3 right here and you count 6 units to the right, you get to 9. If you count 6 units to the left, you get to -3. So there's 6 units from here to here, and we started at 3. Now, they want you to use this nice little pattern they have. I don't know that it really has been greatly helpful for me. More so, I've been using this kind of thought process. What goes in there? So x minus 3 could equal minus 3 could equal what? Well, it could equal 6 or it could equal -6, and then I solve both equations. Okay, you go ahead and try checkpoint number 1. There you go. And 2. Pause it. Come on back. All right. Hopefully, pause it. Here's I've always thought this was kind of funny. Somebody was asked on a math problem, on a test, find x. And the solution, the guy goes, here it is, and he draws a line up and circles it. I thought that was kind of funny. Maybe that's just a math joke, though. All right, hopefully over here, when they say find the absolute value of x that could equal 5, hopefully you got 5, because the absolute value of 5 would be 5. But hopefully you also found -5. The absolute value of -5 would also be 5. And on the other one, you could have followed their pattern and got 3 and 7. I don't know if I'd have done that. I probably would have done this. X minus 5 equals 2, solve it. X minus 5 equals -2, solve it, and got 3 and 7 that way. That's probably what I would have done. All right. So when you're solving an absolute value equation, and this now they kind of come around to my way of thinking a little bit. I don't know. I think we should just be more consistent here. But if I said to you the absolute value of ax plus b equals c, where c had to be greater than 0, obviously because it's absolute value, so it has to be positive, then ax plus b could equal c, or it could equal -c. So, like I said earlier, then you solve the equation, and then you check each solution to make sure that they work. That's where that extraneous solution is going to come in. Do these work? All right. Now, they're going to give us some equations here. Let's switch up our color a little bit. Let's go with this one. So 4x plus 10 equals 6x. That would mean that 4x plus 10 could equal 6x. Because the absolute value of 6x could be 6x. Or that 4x plus 10 could equal the opposite of 6x. Alright, and we don't know. X might be a negative number. We really don't. We don't know. So we're just going to go with this right now. Now, if x was a negative number, that would give us a problem, but we'll find that in a minute. So, on our first step here, we're going to subtract 4x from each side. So I get 10 equals 2x, or I get 10 equals -10x. I'm going to divide this one by 2, and I get x equals 5. I'm going to divide this one by -10, and I get x equals -1. So my two answers are 5 and -1. 5 and -1. Now, I have to determine which, do these both work? You know, whatever, so on and so forth. So on the first one, I'm going to put a 5 in on both. And on the second one, I'm going to put a -1 in on both. Let's see what I get. On the first one, I get 20. 4 times 5 is 20. Plus 10 is 30. 6 times 5 is 30. So 30 equals 30. The absolute value of 30 is 30. So 30 equals 30. That one works. That's great. 5 is a definite solution. Take a look at this other one. 4 times -1 is -4. -4 plus 10 is 6. So I get the absolute value of 6 equals -6. Is that true? Does that make sense? The absolute value of 6 is 6. Does that equal -6? No. That's where you got to stop. Stop, stop, stop. Wah, wah, wah. You know, you got something like that saying, you know what, that doesn't make sense. That's not true. So, the solution is only 5. -1, I'm going to reject because it is extraneous. That's that word we learned about in the beginning. extraneous. So you have to be prepared to reject answers and find extraneous solutions. You go ahead and take a look at 3 and 4. Pause it for a minute. Okay. Hopefully on the first one, you got 3 and -8 for answers. And on the second one, you got 6. And the other answer you got was -2, but you found that that was extraneous and you crossed it out. Okay. So hopefully you worked through those, solved them, and that was what you got. If you didn't get that, go back, try it again, put some time into it. Don't forget, there's a test coming up in a couple of days, and when that test comes up, you're not going to have an opportunity to just copy down what Mr. Emeott writes on the computer. Okay, absolute value inequalities. Remember the whole Pac-Man thing? All right. Let's see. The whole Pac-Man thing. We got Pac-Man here. We color him in, right? And he would eat the little dots. Gobble, gobble, gobble. Right? So, when Pac-Man was cruising around, we had greater thans and we had less thans. The first one is going to be a less than. Now, these are kind of tough to explain, but essentially what we're saying here is when it's less than, it is an and statement, and it's within. So, I'm going to put the word and beside this. Okay? So, when we have less than, the ax plus b, that thing in there, is going to be less than the positive c and greater than the negative c. It's going to be in between the negative c and the positive c. When I have greater than, it's going to be less than, this is those or statements, it's going to be less than the negative c, so it's going to go far off to the left over here, and it's going to be greater than the positive one, so it's going to go bang to the right. Okay, so let me show you how that works. 2x plus 5 is greater than 3. Because it's greater than, that's going to be on that's that or statement. It's either way bigger than 3 or it's way smaller than -3, at least a little bit bigger than 3 and smaller than -3. So that's that or statement we were talking about, and here's or right here. So it's going to be less than -3, and it's going to be greater than +3. Now, this is one of the trickiest concepts that people struggle with. So if you find a way to put that into your brain and make that work for you, great. I always think of it being, you know, kind of like me shooting a water pistol at people, and my reach is only so far. And so if it's greater than 3, then it's beyond my reach. If it's less than 3, if you're standing less than 3 feet away from me, then I could shoot to the left or I could shoot to the right and I could reach you. But if you're greater than 3 feet away from me, I can't reach you. I don't know if that makes any sense, but I hope it helps you. So on this one, I put a less than -3 and a greater than 3, and then I solve it, and so I get 2x is less than -8, and I divide by 2, and I get 2x is less than -4 if I divide everything by 2 here. Okay. On the right side, I get 2x is greater than -2 because I subtracted that 5, and then when I divided by 2, I got greater than -1. So I know I have two things. I got -1 with an open circle. I have -4 with an open circle. It's greater than -1, so it's going this way, and it's less than -4, so it's going this way. I like this little joke here. Dear math, I'm not your therapist. Solve your own problems. I thought that was kind of fun. So let's take a look at example 4. Absolute value of x minus 1.5 is less than or equal to 4.5. So if it's less than, that's kind of how I think of, like, well, then you're less than 4.5 feet away from me in any direction. I can shoot you with my squirt gun. So these are the, you know, this is that and statement. So I'm gonna write and here just so I kind of remember that. So I have x minus 1.5 is either less than 4.5 or it is greater than -4.5. And then I solve that like I did in the last couple sections where it's in the middle, so I have to do something to the right, something to the left, something to the middle. So I'm going to add 1.5 to everything to get x by itself. So I get 6 and I get negative 3. Well, so then x is between 6 and negative 3 because it's an and statement, so it's right there in the middle. Big closed circle on 6 and negative 3. It's closed because we have the line underneath it, right? All right, you go ahead and try 5 and 6. I'll give you a moment. All right, pause it. Start it up. All right, here we go. Hopefully you saw that because this is a greater than, it's an or, and it's one of those that are going to go out to the right and out to the left. And hopefully you found 9 as one of your solutions and negative 5 as your other solution. If you didn't, go back and look at that example again. Go back and look at example 3. It's just like that. You just have to do the same steps. And then 6 is like example 4. So in 6, hopefully, first of all, you saw that these were closed circles because it doesn't have a line underneath the absolute value symbol. And when you found your answers, you found a 2.5. And it's okay to have a 2.5. It's okay to have a decimal as an answer. And 2, and then it was shaded in between. So you maybe wrote something like this. X is less than 2.5 and greater than negative 2. All right. Thanks very much, and we will see you tomorrow. We probably won't have videos for a day or two because we're getting ready for this test. It'll be a great time tomorrow night to check out old videos, check out things that you don't understand, rewatch. I've had kids in the past who just rewatch every video. You know, how do I study for the test? I just rewatched all the videos, did all the checkpoints, and I was ready. Perfect. That's what I want to hear. Thanks, folks.